x and y intercepts with the absolute value and quadratic equations. It's easy to find the intercepts if you just plug in 0 for each variable. I like to start with x. So what's the y-intercept when x is 0? Since y is already isolated, all you have to do is simplify the right side of the equation. 0 plus 3 is 3, and the absolute value of 3 is still 3. So I've got 2 times 3 minus 4, which is 6 minus 4, which is 2. If y is 2, we can write that intercept as an ordered pair, 0, 2. And it's located right here. Now let's find the x-intercepts. Let y be 0. And we're going to solve for x. Since there's absolute values, let's get the absolute value expression isolated. So I'm going to add 4 to both sides. And now I still have times 2, so let's divide both sides by 2. At this point, we can set up 2 equations to solve. So there are going to be 2 solutions for this one. Either x plus 3 is equal to 2, or x plus 3 is equal to negative 2. Let's solve both. So x could be negative 1, giving me the intercept negative 1, 0. Or x could be negative 5, giving me the intercept negative 5, 0. Now let's plot those and see what we've got. We've already got our y-intercept at 2, and now we have x-intercepts at negative 1 and negative 5. So this graph is going to be a V opening upwards. Let's find the vertex. Remember, the vertex comes from this number and this number. If I take the opposite of that, 3, I get negative 3, and then I take the negative 4. So the vertex should be at negative 3, negative 4. So here's the vertex. That's an important point. I could have sketched it without that, but with the V, I really like to get the vertex in the right spot. So now you can see we've got a line that seems to have a slope of 2 going up in this direction and also in this direction. Something like that. Let's look at a couple of quadratic examples. Again, I'm going to let x be 0 and see what the y-intercept is. This is just negative 4, so I've got a point at 0, negative 4. There you go. Now let's let y be 0 and see what the x-intercepts are. If I add 4 to both sides, I get this. If I take the square root, remember there are 2 solutions here. X is either 2 or negative 2. So I have 2. Let's find those. Since it's a quadratic equation, this is going to be a parabola. So sketch in the curve something like this. Let's look at one more example. Let's start by making x 0. Basically what that does is every term with an x in it is just wiped out and you're left with 6, right? So the y-intercept is at 0, 6. The x-intercepts are a little more complicated. So let's let y be 0 and think about what strategy will work to solve for x in this case. We can't isolate x very easily, but there's another method using factoring. Now remember, when we're factoring a simple trinomial with a coefficient of 1, it always starts with x times x. Then we look for 2 factors of 6 that also add up to 7. And here they are. In order to get a negative 7, I'm going to make them both negative. Negative 1 times negative 6 makes positive 6, but negative 1 plus negative 6 adds up to negative 7. Now, why is that helpful? If you have a factor times a factor that equals 0, we know that one of those has to be 0 to make that true. So what we can now do is set up 2 equations equal to 0. Either the first factor is equal to 0, or the second factor is equal to 0. If either of those was true, it would make the entire statement true. So both of them are conditions that we want to solve for. So either x equals 1 or x equals 6. Now let's graph all these and see if this is helpful. So we've got a y-intercept at 6, and we've got x-intercepts at 1 and 6. Since it's a quadratic, this is a parabola, And since we have a point above the two x-intercepts that isn't between them, that means that this opens upward. I can also tell because this has a positive coefficient right here. If you want to find the exact vertex, it's halfway between these two x-intercepts. So let's see, what would be halfway? 6 minus 1 is 5, so 2.5 after 1. 1, 2, right there is the center. And that is 3.5. So if we plugged in 3.5 into our equation for x, we would find where the vertex really is. I'm going to do that using a calculator real quick. Negative 6.25. So the vertex seems to be at 3.5, negative 6.25. And remember, that all started with realizing that these are symmetric around their x-intercepts. So I found the point halfway between my two x-intercepts, which is 3.5 on the x-axis, and I plugged that in everywhere there's an x. So I squared it, I multiplied it by 7 and subtracted, and then I added 6, and I got that the y coordinate is negative 6.25. There's 6 and a little bit more. So my vertex is right about here. And now I feel a little bit better about sketching my parabola. Should have gone through that point. Use your imagination there. On paper, this is so much easier. So I do expect it to be a little bit more round and a little bit more fluid, but that is a fairly accurate sketch. And that is how you can find intercepts and use them to help you graph absolute value and quadratic equations.